Hello students, ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. So welcome to the CET SANKALP classes. So today we are going to start a new chapter, electric charges and fields. So it's going to be a very important chapter. So first we'll be discussing with the synopsis related to that. So while discussing one by one, please make a note of that, the formulas or the concepts. Okay, so one by one, you please make a note of that. Okay, so we'll start with the part. All right, first you should know about what is charge. So you can say that charge is a something that a material objects have and makes it possible for them to exert electrical force and to respond to electrical force. Okay, it is going to experience or produce an electrical force is nothing but electric charge. So electric and magnetic forces determine the properties of atoms, molecules and bulk matter. Coulomb force and gravitational force follow the same inverse square law, but gravitational force has only one sign, while Coulomb force can be of both the signs, allowing possibilities of cancellation of electric forces. This is how the gravity dispersed, being a much weaker force, can be a dominating and more precise force in nature. Okay, so charge is not only a scalar under the rotation, it is always invariant for frames of reference in relative motion. It is not always true for every scalar. That's the thing you have to remember. And you know that properties of charges. So charges are conserved in nature. Charges are quantized. Like charges ripple, unlike charges attract. So that is the concept you would have studied. Okay. After that, Coulomb's law. So Coulomb's law, you can say force of attraction or repulsion between the 2 point charges at rest. So that is very, very important. 2 point charges at rest. Okay, 2 point charges at rest is directly proportional to the product of two charges q1 q2 and inversely proportional to the distance between them. The distance between them. So finally you can say F21 is equal to K into Q1 Q2 divided by R21 square into vector R21 cap ಅಂತ ಹೇಳ್ತೀವಿ. That indicates that it is a unit vector. It is a unit vector. So 1 by K is nothing but the constant term. It is given by 1 by 4 pi epsilon naught. So that 1 by 4 pi epsilon naught value is 9 into 10 to the power 9. 9 into 10 to the power 9 Newton meter square per coulomb. That is the value of K. And please remember the epsilon naught value, that is 8.854 into 10 to the power minus 12 coulomb square per Newton per meter square. Next, Superposition principle, forces between multiple charges. Okay, so it is nothing but just you are going to go on adding. So as you know that the 1.2, 3, 4, 5 different point charges is going to be placed. So all that will be concentrated from the Q1. That is nothing but your superposition principle. So this will be the general formula, 1 by 4 pi epsilon naught summation I is equal to 1 to n q1 q1 qi divided by r1 I square. So when you split it, you'll be getting like this. Okay, right. So these are the points we have to remember, the highlighted points. I think you have noted that. Next is electric field intensity due to continuous charge distribution. So the electric field is nothing but it is a force on a small positive test charge placed at the point divided by the magnitude of the charge. Okay, so divided by the magnitude of the charge. So you can say the electric field due to the point charge is nothing but magnitude of the charge divided by 4 pi epsilon naught r square. It is radially outwards from Q. So you can say Q is positive. So this is very important. So the electric field due to the point charge Q has the magnitude of. So it is radially outward from Q if Q is positive, and radially inwards if Q is negative. If Q is negative. Okay. So like Coulomb force, electric field length also satisfies superposition principle. Okay, that you have to remember. The electric field due to a discrete charge configuration is not defined at the locations of the discrete charges. For continuous volume charge distribution, it is defined at any point in the distribution. For a charge surface charge density, electric field is discontinuous across the surface. So what are the ಯಾವ ಪಾಯಿಂಟ್ಸ್ ನ ಹೈಲೈಟ್ ಮಾಡಿದೀನೋ that is very very important. Okay, next. ಸೊ ಎಲ್ಲ ಬರ್ಕೊಂಡಿದ್ದೀರಲ್ಲ, ಹೈಲೈಟ್ ಆಗಿರೋದಷ್ಟು. Right. Next, the electric field intensities due to various charge distributions. Okay, ಅದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ಬಂದು ಏನು ನೋಡ್ತಾ ಇದೀವಿ, ಪಾಯಿಂಟ್ ಚಾರ್ಜ್. ಕರೆಕ್ಟ್, ಪಾಯಿಂಟ್ ಚಾರ್ಜ್. ಸೊ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಮಾಡಿದಾಗ electric field E is equal to, correct, electric field E is equal to K andre you know that 1 by 4 pi epsilon naught Q divided by R cube into vector R. Okay, so ಅದಕ್ಕೆ ಗ್ರಾಫ್ ಏನು ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲಿ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಏನಾಯ್ತು, E is inversely proportional to R. Next, infinitely long line charge. ಇದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ಗೆ. So in that case, lambda is equal to 2 pi epsilon naught R. Lambda is equal to 2 pi epsilon naught R into R. So ಅದು ಅಷ್ಟೇ, ಇನ್ವರ್ಸ್ಲಿ ಪ್ರೊಪೋರ್ಷನಲ್ ಆಗಿರೋದ್ರಿಂದ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್, ಫೈನೈಟ್ ಲೈನ್. You know that finite line. Thirdly, different cases ಬರುತ್ತೆ x axis and y axis ಅಲ್ಲಿ. Okay, so this thing formula you have to remember, where lambda is nothing but linear charge density. Linear charge density. Okay, right. Next to infinite non-conducting sheet ಆದ್ರೆ sheet ಬಂತು ಅಂದ್ರೆ E is equal to sigma divided by 2 epsilon naught into n cap. Okay, ಅವಾಗಿದು just a straight line ಬರುತ್ತೆ. Next to uniformly charged ring. Okay, uniformly charged ring. So at the center electric field will be 0. So different point ಅಲ್ಲಿ ಇದು 1 by 4 pi epsilon naught q x divided by r square plus x square whole to the power 3 by 2. Next to infinitely long charge conducting sheet sigma by epsilon naught. Next to spherical conducting sphere ಗೆ ಎರಡು ಕಂಡೀಷನ್ ಇದೆ. If small letter r is much greater than capital letter R. Okay, if small much greater than capital letter R, then it is 1 by 4 pi epsilon naught q divided by r square. So if it is less than r, E will be 0. ಆಗ ಈ ಗ್ರಾಫ್ ಪ್ಯಾಟರ್ನ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಕೋಬೇಕು. The two scenarios ಬರುತ್ತೆ. Okay, I hope you are clear with this. ಸೊ ಏನೇನು ಹೈಲೈಟ್ ಮಾಡಿದ್ದೀನಿ, ಸೊ ಪ್ಲೀಸ್ ಕೇರ್ಫುಲ್ ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ ಅನ್ನ. Right, next so uniformly charged. ಸೊ ಇದು ಯಾವುದು ಯೂನಿಫಾರ್ಮ್ಲಿ ಚಾರ್ಜ್ಡ್ ನಾನ್ ಕಂಡಕ್ಟಿಂಗ್ ಸ್ಪಿಯರ್ ಇದ್ದಾಗ ಅಲ್ಲಿ ಎರಡು ಕಂಡೀಷನು ಆರ್ ಸ್ಕ್ವೇರ್ ಲೆಸ್ಸರ್ ದ್ಯಾನ್ ಅಂದರೆ ಇಲ್ಲಿ 0 ಅಂತ ಆಗಲ್ಲ, ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ವೇರಿಯೇಷನ್. ಅವಾಗೇನು ಇನಿಷಿಯಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗಿ ಆಮೇಲೆ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿ ಇನಿಷಿಯಲಿ 0 ಅಲ್ಲಿದ್ದು ಆಮೇಲೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ಅದೇ ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಇನ್ನೆರಡು ಕೊಟ್ಟಿರೋದು. ಸೊ ದಟ್ ಈಸ್ ಅಬೌಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆಯಿತು. ಓಕೆ, ನೆಕ್ಸ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ಸೊ ಏನು, ಇಟ್ ಈಸ್ ಅನ್ ಇಮ್ಯಾಜಿನರಿ ಲೈನ್ drawn in such a way that the tangent at each point on the curve gives the direction of electric field, gives the direction of electric field at that point. Okay, so electric field line is a curve drawn in such a way that the tangent at each point on the curve gives the direction of electric field at that point. ಸೊ ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So next, properties of electric field lines. So field lines are continuous without any break. Two electric field lines cannot cross each other, correct? So the field lines start at positive charge and end at negative charges. They cannot form closed loops. So e property is an upgrade combinator. So based on that, we'll be having some problems related to this. Okay, I hope you are clear. Right. So next is motion of charged particle in an uniform electric field. In an uniform electric field, if the force of gravity does not exist or balanced by some other force, say reaction or neglected, then you can say A is equal to vector F by M is equal to QE divided by M, that is going to be constant. Here equations of motion are valid. So you can say equations of motion are valid. So if the particle is initially at rest, then from V is equal to U plus AT. So we'll get V is equal to QE by M into T. Next, from equation S is equal to UT plus half AT square. So S is equal to half QE by M into T square. The motion is accelerated translatory anta iddaga you can say V is proportional to T, S is proportional to T square, correct? So acceleration is not proportional to T. So then you can say that work done is equal to kinetic energy. Work done is equal to change in kinetic energy. So this will be your formula. Change in kinetic energy, this will be the formula half M QE by M into T the whole square. Next, if the particle is projected perpendicular to the field, then initial velocity condition, if the particle is projected perpendicular to the field with an initial velocity V naught. Navaga V is equal to U plus AT, S is equal to UT plus half AT square. So you can say Ux is equal to V naught, Ax is equal to 0. So Ux is equal to V naught, that is going to be constant. So x is equal to V naught into T. So motion along x-axis, Uy is equal to 0, Ay is equal to Qe by M. So when you see that y is equal to, so s is equal to ut plus half at square ಅಲ್ಲಿ ut will be 0. Okay, half a andre QE by M into T square in terms of charges. So please make a note of all these formulas whichever I have highlighted. So based on that also you'll be having numericals. Right? Okay. So finally ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, when you start eliminating that, Okay, so eliminating t between the equation x and y, we have the equation ಇರುತ್ತೆ. Okay, so if the particle is projected perpendicular to the field, the path will be parabola. So ಈಗ ನ್ಯೂಟನ್ಸ್ ಇದು ಮೋಷನ್ ಇನ್ ಎ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಮತ್ತು ಮೋಷನ್ ಇನ್ ಪ್ಲೇನ್ ಮೇಲೆ ಸೊ ಫಾರ್ಮುಲಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ವರ್ಕೌಟ್ ಮಾಡ್ತೀವಿ. ಕ್ಲಿಯರ್? ರೈಟ್. ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್. So what do you mean by electric dipole? It is equal, it is a pair of equal and opposite charge separated by some distance. It is nothing but electric dipole. So an electric dipole is a pair of equal and opposite charges separated by some distance to a. So you can say dipole moment is a vector. Okay. So electric field due to dipole. So field of an electric dipole, if it is equatorial plane, in its equatorial plane, you can say that the plane perpendicular to its axis and passing through its center. Then you have the equation E is equal to minus P divided by 4 pi epsilon naught R cube. Before that, you will be having the equation as P divided by 4 pi epsilon naught into 1 divided by A square plus R square whole to the power 3 by 2. So condition, if R is much greater than A, you can say that A can be neglected. If you neglect that, you will be getting this equation. So next to dipole electric field. So dipole electric field on the axis at a distance r from the center. ಇದನ್ನ axial line ಅಂತ ಕರಿತೀವಿ. So axial line ತಗೊಂಡಾಗ same equation but 2 into p. Okay, so 2 into pr divided by 4 pi epsilon naught r square minus a square the whole square. Again you can say if r is much greater than a can be neglected. So in that case it will be 2p divided by 4 pi epsilon naught r square, sorry r cube. Same ಅದೊಂದು ನಾಲ್ಕು ಇಟ್ಕೊಳ್ಳಿ. If it is equatorial, it is just p divided by 4 pi epsilon naught r cube. If it is axial, it is 2p divided by 4 pi epsilon naught r cube. You have to remember that both. Okay. Next. So torque on dipole. So torque on dipole. So it is given as vector tau is equal to vector p into vector p cross vector e. Okay. Now work done in rotating an electric dipole from theta 1 to theta 2. So then you will be seeing W is equal to integration of p sine theta d theta. So if you split that, you will be getting integrate ಮಾಡಿ split ಮಾಡಿದಾಗ you will be getting this equation. Okay, that is very important. Next, electrostatic potential is given as U is equal to minus PE, and the U is nothing but 1 by 4 pi epsilon naught Q1 Q2 divided by R square. If you have n number of ಇತ್ತಂದ್ರೆ ಇದು ಹಂಗೆ ಹೋಗುತ್ತೆ. ಇದು 3 for 3 ಚಾರ್ಜಸ್ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದೀವಿ. ಇಂಡಿವಿಜುವಲ್ ಚಾರ್ಜ್ ಮತ್ತೆ 3 ಚಾರ್ಜಸ್ ಕೊಟ್ಟಿರ್ತೀವಿ. Right. Next, angular simple harmonic motion. So if you have angular simple harmonic motion, SHM, simple harmonic motion, ಅವಾಗ ಈ ಕಂಡೀಷನ್ಸ್ ನೋಡ್ತೀವಿ. Okay, when a dipole is suspended in a uniform field, it will align itself parallel to the field Now, if it is given a small angular displacement theta about its angular position, the restoring couple will be so ಹೇಗಿರುತ್ತೆ it is tau is equal to minus PE sin theta. If theta is small, so then you can say PE theta. So tau is proportional to minus theta. That is nothing but angular simple harmonic motion. For the balanced condition, tau deflecting is equal to tau destoring ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂದ್ರೆ if at the equilibrium condition ಇದೆರಡು ಈಕ್ವಲ್ ಆದಾಗ so you can finally find the time period the formula ಮತ್ತೆ angular acceleration ಅಂತ ಕರಿತೀವಿ angular acceleration in terms of moment of inertia in terms of moment of inertia ಇದು ನೋಟ್ ಮಾಡ್ಕೊಬೇಕು ನೀವು ಫರ್ದರ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡಿದಾಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಇಟ್ ಐ ಹೋಪ್ ಯು ಆರ್ ಕ್ಲಿಯರ್ ರೈಟ್ ನೆಕ್ಸ್ಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಓಕೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಅಂದ್ರೆ ಏನು ಸೊ the flux of an electric field through a small area element and the number of lines passing through the surface area normally surface area normally okay so ಅವಾಗೇನಾಯ್ತು delta 5 is equal to E into delta S. So vector area delta S is nothing but delta S into delta vector S is equal to delta S into n cap ಆಗುತ್ತೆ ಅಷ್ಟೇ ಸೊ ಅದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಆಯಿತು ನೆಕ್ಸ್ಟು ಗಾಸ್ ಲಾ the flux of electric field through any closed surface is 1 by epsilon naught times the total charge enclosed 1 by epsilon naught times the total charge enclosed by the surface. The law is especially useful in determining the electric field. Okay, so that time, so Q net divided by epsilon naught. So we are going to discuss the Gauss law in 3 different cases. When it is thin, infinitely long straight wire of uniform linear charge density. So E is equal to lambda divided by 2 pi epsilon naught R into n cap or sigma by epsilon naught into n cap for conducting material. Next to infinitely thin plane sheet charge of density sigma E is equal to sigma divided by 2 epsilon naught for non-conducting sheet. For conducting sheet it is sigma by epsilon naught. Next to thin spherical shell of uniform surface density sigma. So E is equal to sigma divided by 4 pi epsilon naught r square. Outside the shell, it is outside the shell, you can say small letter r is greater than or equal to capital letter R. Next to electric field is 0 ಯಾವಾಗ when small letter r is less than capital letter R and you can say that it is inside the cell. So that is very, very important. So these are the things you have to remember. It's very, very important. Okay. Next, electrostatic pressure. It's nothing but force by area, right? So it is dF by dA is equal to sigma square divided by 2 epsilon naught. A soap bubble or a rubber balloon expands on providing it. Charge to it. So kind of charge might be positive or negative. The next is energy associated per unit volume. So energy associated per unit volume of electric field is U is equal to dW by dV. So epsilon naught E square divided by 2, that is equal to sigma square divided by 2 epsilon naught. Okay, I hope you are clear. So please, I think you're gonna make a note of all the highlighted points. Okay, so ಬೇಗ ಕ್ವಿಕ್ ಆಗಿ ಒಂದ್ಸಲ ನೋಡ್ಕೊಂಬಿಡಿ ಎಲ್ಲ. Right, next. So we are going to see about the important results. So major ಆಗಿ ಏನೇನು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಬೇಕು, ಸೊ ಅದನ್ನ ನೋಡೋಣ. So the first one is the distance dependence of the electric field due to monopole monopole dipole ಮತ್ತೆ quadrupole pole ತಗೊಂಡಾಗ, so E is directly proportional to R square for long range. So E is proportional to 1 by R cube for the short range. So E is directly proportional to 1 by R to the power 4 for the short range. So these are the three formulas you have to remember, how the relation between the distance and the R and E distance of so electric field gu ಮತ್ತೆ distance ಯಾವ ತರ relation ಅಂತ ಹೇಳ್ತೀವಿ. Next, the Coulomb force between the 2 point charges depends only on the charges, their separation and the medium. It is independent of other charge present. So it's very important. So Coulomb force between 2 point charges depends only on the charges, their right. So next is Coulomb force between 2 point charges depends only on the charges, their separation and the medium. It is independent of other charges present. The number of electric lines of force coming out of the unit positive charges given as 1 by epsilon naught is equal to 1.11 into 10 to the power 11. If the cube is placed in an uniform electric field, the net flux through it will be 0. So if the cube is placed in an uniform electric field, the net flux through it will be 0. So this also follows the Gauss theorem. Okay, next, ಇದು very important. The electric field due to the line of charge is proportional to 1 by R. So for a point charge, it is proportional to 1 by R square. Next, to the electric field due to uniformly charged flat sheet is constant on all the points. This means it does not depend on the distance. It does not depend on the distance. The electric field due to uniformly charged flat sheet is constant at all points. This means it does not depend on distance. It does not depend on distance. Next up, the field line is electric field is uniform. Okay, electric field is uniform. The number of if the number of lines of force crossing unit area normally is same at all the points, the line of force are parallel. Okay, line of force is nothing but field lines. So a condition say no. The first condition makes the magnitude of the field to be same. Second condition makes the direction of the field to be same at all the points. The two conditions you have to follow. One is the magnitude of the field to be same. Second one, it makes the direction of the field to be same at all the points. So that is the concept you have to remember. Okay. Next, to find the direction of the electric field at a point, imagine a unit positive charge at that point. Okay, to find the direction of electric field at a point, imagine a unit positive charge at that point. So find the magnitude of the force on it. This gives the magnitude of the field. So you have to find the direction of the motion. Okay. Next, the phenomenon of displacement of centers of the positive and negative charges of non-polar dielectric in the presence of external field. The phenomenon of displacement of the centers of the positive and negative charges of a non-polar dielectric in the presence of external field is called electric dielectric polarization. Okay, right. So ಅದಷ್ಟು ಜ್ಞಾಪಕ. These are the important points we have to remember. I hope you are able to understand, right? So these are the things, these are the synopsis you have to remember. I hope you are clear with this, right? So now we'll go with the first problem. Here is the first problem. The number of charges, the number of electrons. So the number of electrons in 1 coulomb of charge is, okay, you have the formula. Q is equal to Ne. So N is equal to Q divided by E. So Q they've given as 1 coulomb, right? 1 divided by charge is to 1.6 into 10 to the power minus 19. So if you solve that, you'll be getting 0.625 into 10 to the power plus 19. ಸೊ ಇಲ್ಲೆಲ್ಲೂ 0 ಏನಿಲ್ಲ, ಇದು ಡೆಸಿಮಲ್ ಶಿಫ್ಟ್ ಆಯ್ತಂದ್ರೆ 6.25 into 10 to the power 18. So option is the right answer. ಅರ್ಥ ಆಯ್ತಾ? ರೈಟ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಸೇಮ್ ಅದೇ ತರನೇ. Give a try. If a charge on the body is 1 nanocoulomb, instead of 1 coulomb they given 1 nanocoulomb, then how many electrons are present on the body? Then how many electrons are present on the body? Same type try ಮಾಡಿ. So you can say that Q is equal to N E. So N is equal to Q divided by E. So Q is 1 into 1 to the 10 to the power minus 9 divided by 1.6 into 10 to the power minus 9. So 0.625 into 10 to the power 10. So 6.25 into 10 to the power 9. So option D. Okay, next. Okay, two identical charged charged spheres suspended from a common point by two massless strings. So they don't have any mass. Massless strings of length L or initially at a distance D. So they given the condition D is much smaller than 1 apart. Because of their mutual repulsion, the charges begin to leak from both the spheres at a constant rate. The charges begin to leak from both the spheres at a constant rate. As a result, the spheres approach. As a result, the spheres approach each other with a velocity v. As a result, the spheres approach each other with a velocity v. Then v varies as a function of the distance x between the spheres. Okay, so to understand this, you first will draw the diagram. So ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. So there is one of the rigid body there. Okay, so from here it has been x. Okay, theta. ಇದು ಚಾರ್ಜ್ q. ಇದು theta ಆಗುತ್ತೆ. Okay, there is a tension force T that will be split into two components. One is T cos theta, the other one is T sin theta. So ಇದು due to mg. ಇದು ಫೋರ್ಸ್ ಇದೆ ಇಲ್ಲಿ. ಸೊ F is equal to 1 by 4 pi epsilon k q square divided by x square. Instead of r square it is x square. Okay, so ಇದು diagram ಅವ್ರು ಕೊಟ್ಟಿರೋದು. ಈಗ from the figure you can write that T cos theta is equal to mg. T sin theta is equal to k q square divided by x square. ಯಾಕೆಂದ್ರೆ ಚಾರ್ಜಸ್ ಆರ್ ಸೇಮ್ ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ. ಇದೆರಡು ಈಕ್ವೇಶನ್ ಇಂದ ಸೈನ್ ಬೈ ಕಾಸಸ್ tan. So tan theta is equal to k q square divided by x square into mg. ಇದು tan theta ಆಯ್ತು. ಈಗ ಟ್ಯಾನ್ ಥೀಟಾನ ಡಿಫೈನ್ ಮಾಡು. ಈ ಇದೇನು ಲೆಂತ್, ದಿಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಎಲ್, ರೈಟ್? ಇದು ಎಕ್ಸ್. ಸೊ ಟ್ಯಾನ್ ಥೀಟಾ, so it is given as tan theta is equal to x divided by 2l. x divided by 2l. ಸೊ ಈಗ ಏನು ಮಾಡ್ತೀವಿ, ಎರಡನ್ನು ಈಕ್ವೇಟ್ ಮಾಡ್ಬೋದಾ? ಸೊ x divided by 2l is equal to k q square divided by x square into mg. ಸೊ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಎಲ್ಲ ಮಾಡಿದಾಗ q square is equal to x to the power 3 mg divided by 2nk. So from this you can write it as q is proportional to x to the power 3/2. ಯಾಕಂದರೆ other terms are constant. So q is proportional to x to the power 3/2. ಈಗ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, we are going to differentiate. ಏನು ಮಾಡ್ತೀನಿ, dq by dt is equal to 3/2 x to the power 3/2 ಅಂದರೆ 1/2. 3/2 minus 1 is 1/2 into ಏನು dx by dt. Okay. So since dq by dt is constant ಆಗಿರೋದ್ರಿಂದ, okay, it's going to be constant. You can say that ಇದೇನು 3/2 into root x. ಸೊ ಆಗಿದ್ದು 1/dx by dt. So 1/v is proportional to root x. root x ಅಂದರೆ x to the power 1/2. x to the power 1/root ಅಲ್ಲ, ಆಗೇನಾಯ್ತಿದು v is proportional to 1 divided by x to the power 1/2. ಆಗೇನಿದು v is proportional to x to the power minus 1/2 ಆಗುತ್ತೆ. ಸೊ ಆಪ್ಷನ್ ಎ is the right answer. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? ಅಂದರೆ ಅದನ್ನು ಡಿಫೈನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ರೈಟ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. Two spheres carrying charges plus 6 microcoulomb and plus 9 microcoulomb separated by a distance d experiences a force of repulsion F when a charge of minus 3 microcoulomb is given to both the sphere and kept at a same distance as before the new. Okay, the first term. So I'll just solve this here. Space ಬೇಕಲ್ವಾ. So first time force ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, F is equal to 1 by 4 pi epsilon naught. So Q1 ಅಂದ್ರೆ 6 microcoulomb 9 microcoulomb whole divided by d square. ಡಿಸ್ಟೆನ್ಸ್ ಏನು ಕೊಟ್ಟಿಲ್ಲ. ಈಗ ಏನು ಹೇಳಿದ್ದಾರೆ, when a charge of minus 3 is given to both the spheres, then the charge on A ಈಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ, I'm going to take it as F dash. F dash is equal to 1 by 4 pi epsilon naught. So 6 minus 3 is 3 microcoulomb. 9 minus 3 is 6 microcoulomb whole divided by d square. ಕರೆಕ್ಟಾ? ಅವರಷ್ಟೇ ಕೇಳಿರೋದು. When a charge of minus 3 is given to both the spheres and kept at the same distance as before, the new repulsion ಏನು ಅಂತ. So this is equation 1 and 2 ಅಂತ ತಗೊಬೋದು. ರೇಷಿಯೋ ತಗೊತೀನಿ. 1 by f f dash by f is equal to, this both is going to get cancelled, right? So microcoulomb ಅದೆಲ್ಲನೇನು ಮೈಕ್ರೋಸೈಡ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ಈಗ ಉಳ್ಕೊಳ್ಳೋದೇನು, ಡಿ ಸ್ಕ್ವೇರ್ ಆಲ್ಸೋ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್, ರೈಟ್? 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught d square, okay, everything. So now what's left is 3 into 6 divided by 6 into 9. So 6 and 6 get cancelled, 3 ones are 3, 9s are. So f dash is equal to 1 by 3 f. So it is f by 3, option D. ಅರ್ಥ ಆಯ್ತಾ? Next problem. So two pith balls. Carrying equal charges are suspended from a common point by the strings of equal length. The equilibrium separation between them is R. Now the strings are rigidly clamped at half the height. First initially on the height alliತ್ತು, ಈಗ half the height ಆಗುತ್ತೆ. The equilibrium separation between the balls now become. So ಏನಾಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡ್ತೀವಿ, right? Okay, so initially if you take the first diagram ತಗೊಂತೀನಿ. So in the first diagram I can say that this is nothing but theta. Again this is also will be theta. Okay, so at this particular point you will be having, this is the tension T. So at tension T, this is going to be split into two forms. You can say the weight will be going downward, mg. The force is in the opposite direction, so F over there. Now this can be split into two components. So ಇದೊಂದು ಅವಾಗ ಇದು ಥೀಟಾ ಆಗುತ್ತೆ. ಸೊ ಇದು ಟಿ ಕಾಸ್ ಥೀಟಾ, ಇದು ಈ ಕಡೆ ಹೋಗೋದು ಟಿ ಸೈನ್ ಥೀಟಾ ಆಗುತ್ತೆ. ಈ ವೆಕ್ಟರ್ ಟಿ ಕ್ಯಾನ್ ಬಿ ಸ್ಪ್ಲಿಟೆಡ್ ಇಂಟು 2 ಕಾಂಪೊನೆಂಟ್ಸ್ ಆಗಿ. ಈಗ ದ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಇಸ್ ಗಿವನ್ ಆಸ್ ಏನು, ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1/4 pi epsilon naught q square divided by r square. ಈಗ and equilibrium condition ಅಲ್ಲಿ you can say t cos theta is equal to mg, t sin theta is equal to f ಆಗುತ್ತೆ. So when you take the ratio ಆಗೇನಾಯ್ತು, tan theta is equal to, ಅಂದರೆ sin divided by cos ಮಾಡ್ಕೊಬೇಕು, f divided by mg. So f ಅಂದ್ರೇನು, it is 1/4 pi epsilon naught q square divided by r square whole divided by mg. ಕರೆಕ್ಟಾ? ಇದು ಜನರಲ್ ಆಗಿ ನಾವು ಇಟ್ಕೊಬೇಕು. ಸೊ tan theta ಡಿಫೈನ್ ಮಾಡೋದಾದ್ರೆ ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಈ ಟ್ರಯಾಂಗಲ್ ಅಲ್ಲಿ tan theta ಡಿಫೈನ್ ಮಾಡೋದಾದ್ರೆ ಇದರಲ್ಲಿ ಏನು r ಬಂದು r/2 ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಆಗೇನಾಯ್ತು, ಇದು ಎಲ್ಲಿಂದ, ಫ್ರಮ್ ಫಿಗರ್ 1, ಇದು ಫಿಗರ್ 1, ಇದು ಫಿಗರ್ 2 ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಫ್ರಮ್ ಫಿಗರ್ 1 tan theta ಏನು, r/2 divided by y is equal to ಏನಾಯ್ತು, 1/4 pi epsilon naught q square divided by r square into mg. ಇದೊಂದು ಈಕ್ವೇಶನ್ ಇಟ್ಕೊ. ನೆಕ್ಸ್ಟ್ ಫ್ರಮ್ ಫಿಗರ್ 2, ಓಕೆ. ಅಗೇನ್ ಇದೇನಿದು, ಇದು ಥೀಟಾ, ಇದು ಥೀಟಾನು. ಸೊ ಫಿಗರ್ 2 ಪ್ರಕಾರ ಏನಾಯ್ತು, r divided by ಅದೇ ಅಗೇನಿದು r/2 ಅಲ್ವಾ. ಸೊ r ಡ್ಯಾಶ್ ಅಂತ ತಗೊಂತೀನಿ ನಾನು, ಓಕೆ. r ಡ್ಯಾಶ್ by 2 divided by y/2 is equal to same formula. So 1/4 pi epsilon naught q square divided by r dash square into mg, r dash square into mg. ಈಗ ಇದೆರಡು ಈಕ್ವೇಶನು ಡಿವೈಡ್ ಮಾಡ್ಕೊತೀನಿ. ಸೊ ಅವಾಗೇನಾಯ್ತು, r dash by 2 divided by y/2 whole divided by r/2 divided by y, that is equal to 1/4 pi epsilon naught ಕ್ಯಾನ್ಸಲು, q ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ಹಾಗೇನಾಯ್ತು, 1/r dash ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ 1/r ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. ಕರೆಕ್ಟ್ ಏನ್ರಪ್ಪ? ಸೊ ಇದನ್ನ ಫರ್ದರ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ಏನು ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ ಚೆಕ್ ಮಾಡ್ತೀರಾ. ಸೊ r'/2 into 2/y. To r'. ಇದು ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಬೋದಾ? ಸೊ ಅದಕ್ಕೆ ನಾನು ಇದನ್ನು ಅಳಿಸ್ತೀನಿ. ನಾನು ಈ ಪಾರ್ಟ್ನ ರೇಸ್ ಮಾಡ್ತೀನಿ. ಐ ಥಿಂಕ್ ವುಡ್ ಹ್ಯಾವ್ ರಿಟರ್ನ್ ದ್ಯಾಟ್. ಬರೆದಿರ್ತೀರಾ, ಅದನ್ನ ರೇಸ್ ಮಾಡ್ತೀನಿ. ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡೋಕ್ಕೆ ಬೇಕಂತಲ್ಲ. ಸೊ ಪ್ರಾಬ್ಲಮ್ ಮತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ. Two pith balls carrying equal charges are suspended from the common point by strings of equal length. The equilibrium separation between them is r. Now the strings are rigidly clamped at half the height. Separation between the balls now becomes, ಈಗ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ r' ಕಂಡುಹಿಡಿಬೇಕು ನಾನು. ಸೊ r' ಕಂಡುಹಿಡಿಬೇಕು ಅಂದರೆ r' ಕಂಡುಹಿಡಿಬೇಕಂದ್ರೆ using that you can write it as 2r' divided by 2y into 2y divided by r. So 2y cancel. That is equal to ಏನಾಯಿತು, r square divided by r' square ಆಗುತ್ತೆ. ಸೊ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡು. So it is 2r' cube is equal to r cube. So r dash is equal to r divided by cube root of 2 ಆಗುತ್ತೆ. Cube root of 2. So option D is the right answer. I hope you are clear with this. Okay. ಸೊ ಅರ್ಥ ಆಯ್ತಾ? ಸ್ವಲ್ಪ ನೀಟಾಗಿ ನೋಡಿಕೊಂಡು ಕರೆಕ್ಟಾಗಿ ಮಾಡಬೇಕು ಅದನ್ನ. I hope you are clear with this. So thank you. So we'll continue that in the next class. Thank you all.